Hi guys, welcome to my YouTube channel. In today's video, I want to talk about merge sort. Now let's go over some basic concepts of merge sort. Merge sort uses the idea of divide and conquer. And merge sort continuously breaks down the array into halves and recursively sorting elements into the right order. Compared to selection sort and insertion sort, merge sort is a lot more efficient. Therefore, it is good for sorting big arrays. However, merge sort takes up a lot of memory space. Now let's break the code apart. First, we declare the function. Since this is a recursive function, a termination condition is needed. So in here, we state that if length of array is less than 2, then a recursive function terminates. A variable called midpoint is created and initialized to length of array divided by 2 with integer division. Then we return the elements by recursively splitting them apart and sorting the left and right parts of the array into the ascending order. Notice on the last line of the previous slide, there's a call to the merge function, which is another recursive function component that's part of the merge sort algorithm. Again, at the beginning, the termination conditions are stated. The function will terminate if left array or right array is empty. An empty list of results is declared. And the variables index left and right are set to 0. Then the program will loop through the left and right lists, comparing the elements in the list and returning the sorted list. Now let's walk through the code step by step. So first, we have an array A declared containing elements 35, 22, 11, 23, and 13. And then a call to the merge sort function is called. Since this is a recursive algorithm, a termination condition is always going to be stated at the beginning. So if the length of the array is less than 2, then we return the array. A variable midpoint is declared to be the length of array divided by 2 by the integer division. Then we return merge left equals merge sort array midpoint, and then right equals merge sort array midpoint. So when the algorithm goes through first, the left equals merge sort array is going to execute first. So since we already know the midpoint is equal to 2, so 0, 2 is going to be the left part. So the left array is going to have elements 35 and 22. The merge sort function is going to be recursively called, but in this time, the array is actually equal to the left array, 35 and 22, instead of the whole array. So the termination condition is going to be checked, and it is false. And the midpoint is going to be set to 1, since the length of our array right now is 2. And then it's going to return the merge function again, and the merge sort function is recursively called again. Now the left part of the array is going to be 35. So since it's only one element, the length of the array is less than 2. So the condition returns to be true, and a single element 35 is returned. And then it's going to proceed to the next merge sort call, which is the right part, and 22 is being returned in this case. So now we have both the left and the right part, and now we're going to call the merge function. So what the merge function does is basically sorting the elements into the ascending order. So first of all, the two termination condition is checked, and then result is declared as a empty array, and index left and index right is declared to be 0. So 22 and 35 is being sorted. So as you can see that the results that's going to be returned is going to be a list of 22 and 35, which is already sorted. Now the right array is going to be called. And the termination condition is false. And the midpoint of, in this instance, is going to be 1. As you can see now, it splits to two parts, with the left part being only having elements 11 and the right part having elements 23 and 13. So since the left part of the right part array is only one element that is being returned. So as you can see that for the right parts, we still have two elements. So the array is going to split up further apart. So eventually, you can see that 23 and 13 is being broken down to the left side being 23 and the right side being 13. The left side and the right side is going to be sorted. So as you can see, eventually it returns an array of 13 and 23. And after that specific part is being returned, 13 is going to be compared with 11, and since 11 is smaller, so it's going to be placed at the very first position of that right part array, and if after all the sorting, 11, 13, 23 is being returned. And now after we have the left sorted list and the right sorted list, the two lists is going to be merged together. So first, 11 is going to be compared with 22, and since 11 is smaller, so 11 is going to be appended first. And then 13 is going to be compared with 22, and since 13 is smaller, it's going to be appended next. And 22 is going to be compared with 23, and since 22 is smaller, 22 is going to be appended next. And afterwards, 35 is going to be compared with 23, and since 23 is smaller, 23 is going to be appended next. And after 4 elements, its index right is already equal to the length of the right array, 35 is going to be appended next. And this entire sorted list is being returned, as you can see. Now let's kind of go over the general overview of how merge sort works. So first, the array is going to be broken down into two parts. And it's going to be recursively broken down the two different parts of the array until there's single elements. And now the merge function is going to be called, and 22 and 35 is going to be returned from the left side of the array, and the right array it's going to return 11, 13, and 23. And after that, the two parts is going to be merged together. So first, 22 and 11 is going to be compared, and 11 is going to be appended to the list. So the algorithm is going to be comparing the two parts until all of the elements are being added to the list. Finally, this whole list of sorted elements is going to be returned. Thank you guys for watching this video. I hope you find my content helpful, and we will see you next time. Bye!